welcome. Welcome everybody. Welcome to my talk, REST API versus gRPC, which one you should use in breaking a monolith. First of all, thank you for choosing this talk. I know there's also other talks which happen at the same time, so thanks for choosing this one. First of all, let me introduce myself. My name is Vladimir Dejanov. This is my mail, Twitter, blog, and GitHub account if you want to follow me online, or you want to ping me and just ask me something online. I'm part of professional IT scene since 2006. In other words, I'm getting paid to develop software since 2006. And I develop software in many programming languages, frameworks, tools, basically like, all kind of methodologies. I did on all kind of projects over the years. Basically, you name it, I did it. Also, I'm a founder and leader of Amsterdam Java user group. Besides this, I'm giving talk at conferences. And I'm Code 1 star. Basically, it's like similar to the previous Java 1 Rockstar, but because there is no Java 1 anymore, now it's called Code 1 star. But enough about me, what this talk is going to be about. First, I'll be talking about REST and what we actually mean when we say REST. After that, I'll be talking about gRPC, what is gRPC and what it isn't. And majority of the talk, I will basically spend in comparison between the REST and gRPC and how actually they differ, especially when we want to, for example, break a monolith. At the end, there will be some time for questions. So if you have any questions, please wait until the end. And if you don't manage to ask the question, you can always ping me online, via Twitter or mail. I'll be more than happy to answer any questions. Okay, so what is REST? It's a funny question, right? Because we all develop REST for a very long period of time, So why should I start with a simple question like this? Well, the reason for that is that if I would really ask this question to a large number of developers and basically record their response, first of all, I will get a lot of different responses, and the second, a lot of them would be wrong, unfortunately. The reason for that is REST has a formal definition since it was part of a doctoral dissertation by Roy Fielding in 2000. And if you want to read the full doctoral dissertation, this is the URL. It is a very good read, but also it's a very long read, and we don't have enough time to cover it whole. So let's try to look at REST basically in a more compact way. So first of all, it's client-server architecture. There is client and there is a server, so-called separation of concerns. Statelessness. Server has no context about the client, and everything that the server needs to respond to the client request, basically client needs to send in its request. Cacheability. Server has an option to actually say if certain response should be cached and for how long, and everybody should actually, behave in that way. Layered system. Client has no clue if it's talking directly to the server or it goes for the multiple layers before it reaches the server. For example, load balancers, proxies, firewalls, and you name it. Code on demand, well, this is optional. It actually means that the server can send a piece of the code to the client and temporarily extend its functionality. But to be honest with you, I didn't really see this much in practice. And last but not the least is uniform interface, and this is a big part of the REST, but in a nutshell it means that different parts of a system can evolve independently from one another. Well, all of this is really nice, right? But I don't think that your clients or your boss really cares that much about doctoral dissertation. I know that mine don't. They care about applications which actually solve some business problem and basically really add some business value to it, right? So what do we mean when we say REST in real life? Well, it usually means that we have some kind of data source, maybe database, maybe not, but we have some data source, right? And we have our application which actually connects to the data source and then expose this data over the API to the front end. And of course, the front end which actually consumes this data via API. Sometimes our application exposes the data from the database field for field. So exactly as it is in database, it just takes it and basically without any transformation, just exposes it to the front end without any changes whatsoever. And this is so common even that there is like even a name for this, and this is so-called crude REST APIs. They're so common that people very often forget, that REST APIs are much, much more. Again, let's be honest, there can be much more complex situations where you have REST API which actually does a lot of business transformation and things like that, but in majority of the cases, crude REST API is what we built. And for the sake, it's so common that we actually build crude REST APIs that a lot of frameworks in the libraries are helping us a lot to actually do that. So, and this can be seen from this piece of code here. So in this case here, basically I have a class person, which is just a mapping to the POJO, basically a mapping to the table in the database. And if I want to actually expose to create a repository for it, like I just need to, in case of the Spring, I just need to extend, for example, Mongo repository, and the Spring will take care of all the CRUD things for me, like create, read, update, and delete, right? So the database layer, right? So I don't have to do almost nothing, and I will get that for free. Well, if I want to now create a REST API of this, CRUD REST API, I just need to add this small annotation here, and the Spring Framework will do absolutely everything for me. So in this case, basically, to create a CRUD REST API for a table person, I just need to actually to map the person to the table in the database, and the Spring will do everything else for me. And the Spring isn't the only framework in the library which actually does all of this for us, because CRUD REST APIs are so common that majority of the frameworks in the libraries will do most of the work for you. What it's important to remember when it comes to REST is that there is more than one way to do it. So you can do the REST in all kind of ways, with all kind of frameworks, libraries, and languages, as long as the end result comes to the definition of the REST, which I showed with you, it's a REST API. So whatever you do, however you build it, as long as the end result is according to definition, it's a REST API. So it's more than one way to do it. Okay, so let's now look at gRPC. So what is gRPC? Like everybody when I don't know something, I basically start to search for it and see, okay, what it is. And this is what I found for gRPC. gRPC stands for gRPC Remote Procedural Call. Okay, but what the first gRPC stands for? Well, gRPC Remote Procedural Call. So it's recursion of the name. Somebody thought it's very nice and funny name. For us, what's important is that gRPC is Remote Procedural Call framework with a lot of goodies baked into it. So remote procedural calls are not a new thing. They have been with us for a very, very long period of time. So for example, if we are constantly only staying in the Java land with the clients and the service and everybody, we could use RMI, right? And they're very good to use. The problem with RMI is that it's only Java. So as long as you want to move outside of JVM, you can't use them anymore. So that's why we had Corba, right? And everybody loved Corba. To be fair with you, I never used Corba in my life, so I really don't know how good or bad it is, but I know there was a lot of love for Corba, and when Corba was finally kicked out of the Java ecosystem, a lot of people were very happy, so probably they did something wrong. With any RPC framework, in a nutshell, what we have is a server which actually exposes some procedure to call remotely, right? In this case, it's written in C++, and then we have one or more clients which actually can call this procedure remotely, and in this case, it's in Ruby and Android Java client. So the reason why actually here you have like C++ for a server and then the clients are in Ruby and in Android Java is because majority of RPC frameworks are language agnostic. Majority, not all. In case of gRPC, out of the box it supports C++, Java, Python, Go, Ruby, C#, Node.js, Android Java, Objective-C, PHP, Dart, and from a few days ago there is also something called gRPC Web. I'll talk about that a little bit later. But what I would like to stress here are these languages, because with these languages, all the native mobile development basically is covered, and majority of the backend systems. Okay, so now we have rough idea what REST is and what gRPC is, but okay, which one should we be using in breaking down the monolith? What's the differences between them? What's the good side and the bad side? So let's look at that. So imagine that we have one big, beautiful monolith, right? Solid as a rock, which we all love. And we want to go basically from this state, one big state, to multiple microservices which talk to one another. Or, for example, you're building completely greenfield project, so you want to basically start to build something and you want to end up with a distributed system, again, with a lot of parts of the system which talk to one another. Logical question that you're going to ask yourself is, okay, but how do actually they talk to one another? So how do they actually exchange information between them? Well, we can use REST APIs, right? Because we know them very well, we know that we can exchange information with them, so we can use that. But on the other hand, maybe we can also use gRPC, right? So which one should we use? Well, if you look just from the sidelines, probably the chances that we know REST APIs are much better. We probably have much more knowledge into REST APIs, the ecosystem, all the libraries and frameworks that we know and use every day is much bigger there, right? But the other side, like if you think, okay, we had a monolith, right? And in that monolith, we basically had the pieces which called one another. So basically, we had method calls which were internal. So when we break up the monolith, what we end up is, again, microservices, But again, they are going to call the same methods, but just over the wire. So in that case, maybe gRPC or any other RPC framework will be very good, because we can keep the same logic, keep everything the same, just instead of basically calling internal method calls, have remote method calls, right? So let's look at it a little bit more details. So both REST and gRPC support multiple languages, right? Let's be honest, REST supports much more languages, because you can write REST in any programming language which you want, including assembly if you want, I wouldn't, but your choice. Like I said, with REST, there's more than one way to do it. We can do whatever we want to do. We can choose the language, we can choose the libraries, we can choose the frameworks, we can do everything basically customized as we want and as we need. The problem with that is that also we have to think about every single thing. How basically request looks like, how response looks like, which resources we're going to expose, which status code we're going to use, especially in the case of the error or the caching, things like that. So we have a lot of options, but we also have to choose a lot of stuff for us. In case of gRPC, there isn't really a lot of choices. There is only one way, gRPC way. The only thing that you need to choose is you choose the language that you want to do, and then gRPC will take care of for the most things for you. The only thing left for you is to actually add the business logic. So the starting point in the case of gRPC would be, of course, official website where you can actually go, read more information about it, documentation, and nuts and bolts about gRPC, what gRPC is. And then here you will see there are a lot of quick starts, tutorials, documentation, examples in all kind of languages. So there's a lot of good documentation here that you get for free. Of course, what you would do is first choose the language which you want to do. In my case, it would be Java. So basically, I would go to this URL, and here I can see examples of the servers or the clients and all the things basically that I want to do and build. Communication in the case of gRPC is happening asynchronously, and basically the client and server are sending messages in both ways. In case of error, basically the server will inform the client that there was an error there. And let's look how that communication looks like. There are 4 types of communications. First type is basically client can send a single message to the server, and server can send a single message back. Then the client can send a single message to the server, and server can actually send multiple messages back. Then the client can send multiple messages to the server, and the server can send single message back. And the fourth, you probably guessed, client can send multiple messages to the server, and the server can send multiple messages back to the client. So there's only these 4 types. So I'm fair to say that REST supports more than 4 types of communication. Maybe that's a good, maybe that's a bad thing. Depends from situation, right? So let us look now a little bit more into internals of gRPC. gRPC consists of 3 big parts. Part number 1 is IDL, or Interface Definition Language. So in the case of gRPC, and this is like the first big difference, well, not really big difference, but difference between REST and gRPC. In case of REST, as we all know, schema is optional. You can have it, but you don't have to have it. In my mind, it's a very good option to always have a schema, but if you don't have a schema, everything will still work. Even if you decide, okay, I want to have a schema or not, if you say, let's say, we want to have a schema, again, you have an option. I can first write the code and then use a notation to generate the schema, or I can actually first write the schema, then use some library or framework to actually generate all the steps for me and get the code. In case of gRPC, like I said, there is only one way, and that is schema first. You have to write schema first, and then using the schema, all the stubs and everything is going to be generated for you. All the POJOs, all the messages, or the client, or the server, all the stubs will be generated for you in the language that you care about. So this is, for example, a snippet of a schema. And here I define some message, which is going to be sent across, and I call it transfer money. Here, basically, I have some fields, and you can see, like always, okay, there's a type of a field, then the name of a field, and basically there is like some number in the end. We can ignore it for now. And then here's how you define the service. So I'm here, in this case, I'm defining service by the name of the bank, and I'm saying, okay, I have one RPC, which is actually going to be here. It's going to be called transfer, and client is going to send transfer money message, and as a response, the server will send transfer confirmation. That is in the case if it's one-one communication. So one message from the client, one message from a server. If, for example, the server wants to send multiple messages back, well, you just put stream, and the other way around. Again, like if you want for a client to send multiple messages, you just add stream, and that's it. Okay, the second part of gRPC is HTTP2. HTTP2 helps a lot with throughput and amount of data that can be sent across the wire, and also it helps a lot with the fact that both sides can talk at the same time. What is important to remember is that HTTP2 is baked into gRPC. You don't have to do anything about it. You are going to get it for free and all the benefits that it actually brings. In case of Java implementation, it's you have net embedded basically in your server. So when it comes to REST, well, REST comes from the HTTP1 era. It will also work perfectly with HTTP2. However, depending on all the choices that you made, language, library, framework, application server, and all those kind of things, maybe you get HTTP2 for free, maybe you need to add extra work. So it all depends. With gRPC, you get it for free. The third part of gRPC is the protocol. Protocol which is used actually to send the messages across the wire. Again, if you don't do anything, if you just basically take the gRPC out of the box and basically just start it, you're going to get protocol buffer free for free. You can also plug in different protocols if you want, but I haven't really seen it that much. I don't have a lot of time to actually go into all the details about the protocol buffer free, so if you want to read more about protocol buffer, I suggest you just go on this blog post. In a nutshell, the things that are very important for us to understand is that protocol buffer free is a binary protocol. Second thing is that the protocol buffer free has a schema. Like you can think of it as XMLs and XSDs. So basically you have a schema which you can actually use to validate all the messages and the validity of the message and if all the fields are there and all those other kind of things. This is a very good thing with protocol buffer free because it means that your code is going to be much less, because you don't have to worry about all use cases. Okay, do I have this field? Do I don't have it? Is it of the right type? And all those kind of things. If you don't want to read but just want to watch video about the protocol buffer free, then this is also a very good video. I know the speaker; he's a good one. Yeah, you can guess who it is. But the important message that I want to point out is that REST isn't JSON over HTTP. So we can do REST with any kind of protocol that we want, including the protocol buffer. So you don't have to use JSON for the REST. But let's be honest, in most cases, when you're building the REST API, you're either using the JSON or XML as a protocol. Okay, so let me now show you one graph here, which actually says that JSON is much, much, much worse than protocol buffer, right? Because protocol buffer is much better. Or maybe it's not. So, but first of all, what I'm even showing you here. Whenever somebody is showing you the graphs, be very critical. Always ask, okay, how do they get the numbers? What actually the graph represents, and what's their, point that they want to make. In my case, the numbers are made up. So, they're not valid. However, the point is valid. This one here actually shows the throughput of the data. And if you think about it, JSON is a plain text protocol. Protocol buffer is a binary protocol. So it shouldn't come as a surprise that we can send more data over the binary protocol instead of plain text. It's fair to say if you take the JSON and if you zip it and do some other fancy stuff, the difference will not be that huge. This one here, on the other hand, shows the CPU load while you're actually marshalling and unmarshalling the data. And again, if you just stop for a second and think about it, this also shouldn't be as a surprise for you. Because in the case of the JSON, we have plain text without the schema. On the other side, with protocol buffer, we have binary protocol which has a schema, So it should make sense that marshalling and unmarshalling binary data with a schema definition is less CPU intensive. If I'm honest with you, if I'm building something on my laptop just for demos, then this shouldn't really make a lot of difference. It doesn't really care is it JSON or the protocol buffer free. However, think about your users. If your users are on a device which isn't really CPU powerful, then this means a lot. For example, if they're on a mobile phone, if you do something CPU intensive, you're going to drain their battery and you're going to actually make their user experience very bad. So in that case, it makes sense to use protocol buffer free. Again, if, for example, you have a lot of systems and those systems are basically running in the cloud, and you're paying your bills per CPU usage, then again, this will make a lot of difference, in the amount of money that you will have to pay in the end of the month. And I think that we all want to have smaller bills. Okay, like I said, you can build the protocol buffer with the REST, but be aware because browsers don't really understand the protocol buffer. With the gRPC web, actually they created some libraries and some JavaScript front end and some proxies that kind of help the browser actually understand the gRPC. But it's kind of new, so I didn't really look into all the details, and I'm not sure if it works perfectly with all the frameworks that we have in the front end, and how it works. So be aware. If you're going with the protocol buffer with the REST, maybe your frontend will not understand it. Okay, so let's be honest, all the things that I talked to you so far are not really big differences, right? They're like, okay, there are differences, but not really like huge ones. So let's look now actually at the real big difference between the REST and gRPC. And the big difference is REST is all about resources. So it means that basically when you're solving some problem, you have to think, okay, which resources do I have? Basically, how would my response look like? How request looks like? How response looks like? Which parameters do I pass? Which status code do I going to look? But you need to model it in the resources. On the other hand, with any RPC, it is all about remote procedure calls. So here you don't really care about the resources, you care, okay, like which procedures do I have, and I'm going to call them remotely. So it's a different mindset to solving a problem at hand. So let's look at a simple example. So let us assume we have a user A. And user A wants to send the money to user B. And because we all love to pay taxes, we use the bank, right? To send the money. So in this case, what we're going to do is user A is going to send a request basically to the bank, says, okay, transfer money from my account to account of the user B. And bank will transfer the money. Of course, you would like to also know, like, did it succeed or not? Did it basically pass, especially if you're paying a bill for like electricity and the internet, things like that. So the bank will also send back information to user A, okay, like it succeeded or didn't succeed. So think about, okay, if you need to actually solve this problem, how would you solve it with the REST? You can solve it with the REST. A lot of people actually solving problems like this every day with the REST. But does it really fit naturally into it? Where are the resources here? Like how actually request and the response look like? Like transfer the money, what's the resource there? Again, like if there's some error, which status code do we use? For example, like you don't have enough money on the account, or basically the account that you're sending the money to isn't valid. Or maybe, everything is valid, but the amount of the money that you're sending is just too big, so the bank wants to make sure that nobody hacked your account, but it's actually you. It doesn't really feel natural to solve problems like this with the REST. On the other hand, if you go with gRPC route, then the only thing that you need to think is, okay, I have those 4 types of communications. Which type of communication I use to which part here? So, for example, this part here, well, okay, I'm user A, and I send to a bank, say to a bank, okay, transfer money from my account to some other account, and I want to hear it back. Well, it's one-to-one. I send one message to the bank, and the bank sends a message back to me. Okay, what about this one? Well, I have a user B, right? And this user B doesn't do anything. He just gets notifications on his balance account, right? So you can imagine, okay, he's somewhere on a mobile phone, so he logs in and says to bank, okay, this is my bank account, and I want to hear, like, whenever somebody either take the money from my bank account or put money in my bank account, well, and then it means like basically the bank sent multiple messages back to the client, which means like one too many. Or, for example, what happens if the user A and B are in different banks? Which is a very common thing. Well, in that case, basically the bank of a user A needs to talk to the bank of the user B and exchange information about the money. But if you think about it, probably these 2 banks are communicate about a lot of stuff. So they are not going to create one connection per user request. They're going to create one communication and leave it like up and running for a long period of time, which means this is like many to many. Bless you. So, like I always say, talking is boring, so let's look at the code. By the way, is this big enough for everybody? Okay, cool. So, this is my basically schema for my gRPC, and like I said, first thing first, I need to define message, basically which I'm going to send. So in this case, when I'm transferring the money, I call a message, transfer money, and then here basically I say, okay, transaction ID, so that I can actually follow it. From account, I'm going to send, to account, I'm going to send, amount that I'm going to send, and I have a message basically to say, okay, like, here's the bill or things, here's the tip or whatever. Then also I need the message which is coming back. So in this case I have a message which is called transfer confirmation. And then here I have transfer ID. I have a status, basically, and for the status I can show you here, it's basically, it's an enum, so I can also use like enums and basically use messages inside the messages. So I can really like say here, like say it's success, failed, confirm needed, all those kind of things. So I can really say this. And again, also I have a message, something usably readable. So then let's go to the RPC. Okay, so here's the RPC. So here I define service, I call it bank, and I say, okay, I have RPC, remote procedure call, which is going to be called transfer. I expect from a client to get a transfer money message, and I will send back to the client transfer confirmation message. So first thing first, you write a schema like this. Then you actually try to build your code, and then gRPC is going to generate all the stubs for you. So I'm not sure if you see it here. Is this big enough, this part here? Yeah, so basically this is in target generated sources. There is protocol buffer, and then in gRPC Java, where actually there is my gRPC implementation. And here in basically the package which I mentioned are all my messages and helpers, and everything is generated for me. So then let's build a server, right? To build a server, we just need to do this. Basically we say server and server builder for port. And basically I say here which port I want to use. In this case it's 1990. Then I say build, and that's it. It's going to build the server for me out of the box. Then I need to start it. And the only thing that now I need also to do is say await termination, because everything in gRPC is async. So if I just start the server in the main thread and don't put await termination, it's just going to kill my whole application right away. So you can also see here, I have something called add service, and I have some class here. By default, gRPC is going to create all the stubs for you, including all the RPC messages. So you can just start it, without implementing any business logic at all. However, if you do that and somebody calls your remote procedure call, it's just going to say, I don't know what to do, I'm just a stub. So in order to actually help gRPC resolve the stubs, we do the dependency injection this way, where we just say, okay, add service, and we add our class. And in this case, again, gRPC is generating everything for us. So what we need to do is we just need to extend bank gRPC, bank impl base. And this is, again, the server stub, which all the boilerplate code and everything that we will need for our server. The only thing left for us is to add the business value, the business logic. So in this case, I want to add transfer method. So I'm going to override public void transfer. So you can see if I go back to bank proto, it's exactly the same name like here, right? So it's transfer here, and the method is called exactly the same. And then here, I get transfer money request. Basically, this is the message that the client sends to me. But look, I return void, which is kind of strange because I should send message back also right to the client. Well, that is done through the parameter, which is called stream observer of the type transfer confirmation. So basically here, I do the business logic. I take request, I do whatever I need to do, and as a result, I create transfer confirmation. Then I take response observer and call on the next and provide the message that I'm sending back. So important thing here is if I say response observer, and I say on, I have three things here. I have on completed, on the next, and on error. On the next basically means, okay, I'm sending this message to the client. And again, you can see, in this case, I can say multiple times, okay, on next, on next, on next, and send multiple messages back to the client. However, in my case, client expects only one message, so if I send multiple messages back to the client, I'm going to crash the client. So be aware of this. In the case of any type of error, I just call on error, and that's it. If when I'm finished with everything, I just call on complete, and I let the client know, okay, I'm done. I send all the messages that I need to send to you. So that's all that basically you need to do to send the message back to the client. I would say it's very easy, right? Okay, so let's look at the client. So with the client, it's a little bit more complex. So in the case of a client, first we need to create a managed channel. To build a managed channel, basically we go managed channel, builder, for address, and then we provide the address, in this case localhost, and the port, what we want to do. Then here I'm providing use plain text equal true because I'm doing the demo on my laptop. By default, as I said, gRPC is using HTTP2. HTTP2 comes with HTTPS basically by default. So if you don't want to deal with all the securities and things like that, in development you can just use plain text and you will be good. Don't do this in production. Then you just do build and that's it. You have a channel. Then here I'm building a client. So as I said, gRPC is asynchronous. And remember that. However, client can choose if you want to be blocking or not. So if I go here and just say bank gRPC, yes, and then I say new, I have three options here. I have a blocking stub client, which is actually going to be blocking client. Then I can use basically asynchronous client using the steps, or this asynchronous client using the future. So the client can choose if the client want to be like blocking or not blocking, but from the server side, everything is asynchronous. In this case, because I don't care, I'm just using the blocking client, and I just provide it with a channel. Then here, basically, I call client.transfer, and here I provide the message which I want to use to send to the client. And you can see the gRPC is really heavily using builders. So everything is done via builders. All the messages, everything is via builder. So in this case, I'm transferring the money with a new builder. I'm setting transaction ID. I'm setting from account. I'm setting to account. I'm setting amount. And then I do build, and I get the message. I call the transfer, and I will get response back. Okay, in this case, I don't really do anything clever. I just print it out, and that's it. Okay. So let's just look now how I actually do the notification part. So again, let's go back to the protocol buffer. So in the case of notification, there should be somewhere, okay, I don't have it. There it's like somewhere below. Money. Okay, yeah, so basically I have here, I have account, basically message account, which I'm going to send when I'm going to basically, for each account I'm expecting notification. I see here only account number. And then basically here I have a message. It's going to be account notification. Again, I provide here account number for which it is notification, the type, the amount, and then basically notification type. Again, this is also enum. What I could do is actually just do here account. So you can even do something like this. And it's going to work. So basically you can have a message inside the message. You can even have a private messages, basically, which are not going to be visible outside of a message. So if I just created some message here, I could have it also here, and then basically I could use this message inside account notification, and it can be reused outside of it. So then, like I said, I want to actually do notification. So again, it's RPC, remote procedure call. I call it listen to notification. I expect a message of a type account. And I'm going to send back account notifications stream, which means basically more than one. So in the case of when you're sending basically data between the two banks, I'm just going to add like here below, stream on both sides. So basically I'm going to get stream here and stream here. So that's the only difference that you need to do if you're sending a single message or multiple messages back. Okay, so let's look now actually how the service looks like. So it is, no, it's notification. Okay, so listen notification. So again, it's very similar to the transfer one. Again, I have account request, message which comes to me. The second one is basically stream observer of a type of account notifications. And I'm just doing basically here multiple times on next, on next, on the next, on next, on next. That's it. Very simple. So if we look into notification client, again, it shouldn't be, there's no differences there. Again, I have a channel, which again I'm doing for address, localhost, port 9090, use plain text build. Again, in this case, again, I'm building using the blocking client. And basically, okay, I provide some value, and I'm going to get back when I call it, iterator, that basically then I can just call and print, do whatever I want with the messages. And below here, I call while, iter has next, and basically I do some notifications. Simple as that. Okay, so let us look now at more complex situation, and that's transferring the money. And that's the most complex one. So when I'm transferring the money, let me just show you quickly here. So it's request transfer. I have stream on one side, and I have stream on another side. And you will see this one is kind of different than what I showed you so far. In this case, it's called, okay, request transfer, but it is sending back stream observer of request money, the data that comes from the client to the server. This is kind of, counterintuitive. And the method that parameter that I'm getting is request status, which is basically actually what I'm sending back. So, if you think about it, what would be logical, to do in this case when you're actually sending messages and receiving messages, this kind of other way around, because I'm returning what actually I'm receiving, and I'm receiving what I'm returning, So it's kind of counterintuitive, but, you get used to it. So the first thing that basically you do is you just say return, new stream observer, request money, and then you need to define 3 methods. On the next, on error, and on completed. Basically, okay, like when I finish, what do I do? When there is error, what do I do? In this case, I'm just going to send an error. And basically here, okay, what do I do when I get request? And basically in this case, I create some response and basically I send message back. So not really a lot of crazy stuff, and some other stupid stuff below. And if we go to the request client, okay, so in this case, again, we have a channel. So the same thing here, like in all previous examples, no difference here. We, again, man the channel, address, use plain text build. In this case, I'm using the asynchronous client, because in this case, I can't use the blocking client because it's going to be streams going back and forth. And here, basically what I say is, okay, on the client, request transfer, and then here, okay, let me just put this in a new line so you can see. I say new stream observer request status. And basically here then I decide, okay, like what do I do? Okay, in the case of the onNext, so when I get the message, when the client gets the message, this will be called. In this case, it just prints the value. If it's an error, I just terminate the connection, and when it's completed, again, I just, terminate the connection. And you will see that here, basically, I get back stream observer of request money. This is basically what I'm sending to the server, and we're going to use this client server below, client observer below. Basically, I'm just using it here and checking, okay, is the channel shut down? No. Then I'm just basically going to send messages to it. That's to it. Basically, it's like those 3 types of examples, and the 4th one is very similar to this one. So the code is on this basically page, and you can actually download it and you use it and look at it, in more detail if you want. So you don't really have to if you didn't catch everything now. Okay, so I kind of talked about gRPC, I talked about the REST, I talked what are the differences between them. Now I also want to actually mention my personal view about the differences between gRPC and the REST. And goes like this, if we had one big axis, very big one, and then on one side we had Wild West, cowboys and Indians and all these kind of things. And on the other side we have a law and order. In my mind, REST would go somewhere here, because it's like more than one way to do it. You can do whatever you want to do, as long as the end result is according to definition, all is good. Majority of the REST APIs that I saw and I dealt with during my life, unfortunately, come here. No schema definition, no documentation, no anything. Good luck. On the other hand, gRPC actually comes here. And it comes here because, like I said, it's very opinionated of how things should be done. There are hooks that you can actually use to actually plug in and do some other stuff, but only where gRPC thinks that it's valid. This is also a very good thing, because it means that if you work on one project with gRPC and you go to another project with gRPC, your startup time will be very fast. You just need to find the schema definition, basically, the protofile, read it, and after that, everything will be more or less easy for you. Because again, there is only one way how to do it, gRPC way. Also, we should ask ourselves, some questions, before choosing, okay, should I go with REST or should I go with gRPC? And here are some questions that I would ask always. First thing first is, who will be the consumer of your, whatever you're building? So, will it be mobile? Will it be web? Will it be some other person? And again, depending on the differences that I mentioned during the REST and gRPC, you can actually choose, okay, which one will serve better in this case. If it's going to be somewhere in the backend and going to be a lot of calls, then gRPC is probably going to be better, because with protocol buffer, with HTTP2, you can send much more data, and you can basically squeeze the last byte out of the network. Also, it's very good, in case of the mobile phones. In case of the web, well, before the gRPC web, which was became public a few days ago, I would always say you can't use gRPC, but now it looks like You can use it, but I'm still not sure how good gRPC web is, in day-to-day work. They say it's production ready, but depends whose production. Then the second thing that you should always ask yourself is, okay, what is the use case? What is the use case for the thing that I'm building? Is it like CRUD or something else? And again, if it's CRUD, then I would just run toward the REST right away, because there's so much frameworks and libraries, and the ecosystem is so huge and good and battle tested that why would you even care for anything else? Can you do the CRUD in gRPC? Yes, you can, but should you? I don't think so. Then this might come as a surprise, but what are internal policies and rules in your company or company that you're going to work towards frameworks, protocols, and others? This might sound strange, but believe me, from my personal experience, I worked with the companies which said nothing related to the free software, nothing related to GPL. Also, some companies said nothing related to open source. We have to all build like our own frameworks because we're the cleverest people on earth. Sometimes they say all the communication has to be over JSON and everything has to be REST because like build our whole system and ecosystem around it. So in that kinds of cases, like there isn't actually a question what to use. It's already decided. And I think the most important question that you always need to ask yourself is, what is the problem that you're trying to solve? So again, like I said, the big difference between the REST and gRPC is actually how you fit your model, how you actually think about solving the problem. In case of the REST, it is resources, it's basically response, request, status codes. You need to think, okay, how this box combine. In case of gRPC, it's basically procedures that you call remotely. So again, what type of problem you're trying to solve, which actually way of thinking and solving the problem fits more naturally and better. Thank you. This is all resources that I actually mentioned throughout the talk. So we have 3 minutes. Any questions? Yep.
How do you handle security and authentication using gRPC?
Okay, so the question is how you're using authentication and security by gRPC is basically taken care of for you. There's basically the files that you can just include, and then it's going to like be TCLs and all the things. Basically, all is taken care of for you. It's very like plug and play. And they say, okay, like for this, just do this, for this, just do this. There's like even different ways how to include the files and keys and everything. So it's, again, like I didn't mention, but gRPC actually originated from the Google, and basically there are internal systems which are calling to one another. So that's why the stress was make it secure and make it very performant, because when you're making like millions and millions of calls, if you're just sending 1 byte more, then it's going to hurt you. Yeah. Any other questions? Yep. Sorry, can you repeat?
If I want to use big decimal type,
Okay. I didn't show you, but let me just try to quickly go. There's somewhere, should be gRPC Scholar. It was this one? Yeah, maybe. There is somewhere Scholar. So you have a long list of the things that you can use here, kind of. So if it doesn't fit basically in this, so there's like this is like the primitives, and it doesn't make sense here. Then basically you need to create your own message and do it. Does this answer your question? Well, 632, 664. Okay, this is 6 boolean string bytes string. Well, then it looks like you would have to play a little bit with it. Or maybe there is like some extension, because there is like gRPC, but there is also extension gRPC ecosystem, something like that, where you actually have a lot of other stuff. So probably there's something for that. Any other question? Yep. Okay, so the question is how you do the reversioning and backward compatibility. So that's a big difference between protocol buffer 2 and the protocol buffer 3. So protocol buffer 2, for the fields, you can say, okay, it's required or it's an optional. In case of protocol buffer 3, basically they said every single field is optional. Reason for that is because they saw precisely when you want to do it backwards compatible, it's going to be really painful and difficult if you have fields which are required and you want to remove it. On the other hand, if you make everything optional, then even if you remove it, like everything will still work because it was optional from the beginning. So that's how they solve the problem with backwards compatibility. So they don't need versioning, everything is optional, deal with it. Any other questions? Yep.
Exception handling. So basically, when we send back as a result, what we saw in our we are using gRPC, you cannot actually send a closure return, an exception message. But you have to send
No, you don't have. So the question is what you do with exceptions and everything. I know that basically gRPC by default provides some exception types. Then you can extend and basically send them back. So you don't have to send string. You can send the whole objects back. I don't think that I have an example, but there is something. I don't have it at hand here. I don't know it by yeah, on error. Yeah, basically you call on error, and basically here there's like already some predefined stuff from the gRPC that you can use and you can extend, or you can just throw it like this. But you can send the whole objects and everything. Like maybe for some things you need to do a little bit more work, but and you don't have to send string. You can send the whole objects and everything. Okay, I'm done with the time. Thank you everybody once more. You were a great audience.